Expedition 2 Atom Land Landfall amongst the atoms, dead mice, the sun and the standard model of chemistry. Don't mention the modes. A brief trip backwards, attention to the electron and avoiding the pilot into the atom land. Pudding or planets, the music of atom land, a guitar lesson, shells and Schrödinger. What you are talking about? So poetic. I don't get anything. Okay. Atoms. Having prepared ourselves for the fact that the object we encounter will be the strange amalgam of the wave and the particle, we approach the shore of Atoms land with confidence and excitement, eager, and we think well prepared to explore the interior. We disembark and head off on foot. An atom is the smallest indivisible fragment of the chemical elements. Think back to the fiberglass of our boat and the silicon that fiber are made of. We are already peered briefly inside the silicon atom, observing the nucleus and especially the electrons around it. If we were to break up an atom of the silicon, what we would get might be interesting, but it would no longer be silicon. Yes. Everyday materials consist of different chemical elements, each one of which is a different kind of atom, sometimes bound together as molecules. The idea that there are indivisible building blocks to matter may date back to the ancient Greeks, but the knowledge that atoms are real was the result of the careful exploration over the last 2 centuries. Much of that exploration was not done directly with high-resolution instruments probing tiny structure. It was done by observing the properties of the different materials, identifying how they combine and react with one another, and weighing them precisely. Most of the elements were discovered between 1745 and 1869 by many different explorers using a wide variety of the inventive techniques, including testing, smelling, weighing, or simply observing the property of various materials and the products of the various reactions between them. Yes. For example, several scientists working independently in the 1760s worked out that air contains 2 major components, one of which would allow flames to burn and make mice more active and healthy, while the other would put out flames and suffocate mice. In the 1770s, the mouse-friendly gas, which was also produced by heating mercury oxide, was identified as the element oxygen. Yes. The king of... No. The oxygen. A Scottish student, Daniel Rutherford, guessed that the mouse-killing gas was another element, nitrogen, in his 1772 doctoral thesis. Wow. Astronomy was also employed, being responsible for the observation that there was a new element present in the sun, not previously known on the Earth, but identified by the distinctive frequency of the light it emitted. Wow, I didn't know that. It was named helium after Helios, yes, the sun, the Greek god of the sun, yes, and was later identified in the gases emitted by the Mount Vesuvius in 1895. Swedish chemist Per Theodor Cleve and Niels Abraham Langer noted that the same gas was produced by dissolving certain minerals in acid. Wow. And managed to isolate enough of it that they could measure its atomic mass. Wow. John Dalton, a chemist, physicist, and meteorologist working in the 19th century in Manchester, concluded a series of the enormously careful experiments combining, reacting, and weighing various gases and other substances, and established that some materials involved in the various chemical reactions always combined in a fixed ratio. He hypothesized that this was due to the fact that the reaction was actually taking place between tiny fractions of each materials. The tiny fractions of each materials. These tiny building blocks possess, he believed, the certain well-defined ways of combining and recombining to make new stable building blocks of the new materials. Wow. Carbon dioxide, for example, could be made from combining 2 parts of oxygen with 1 part of carbon. Water could be made by combining 2 parts hydrogen with 1 part oxygen. If you get the ratio right, all the initial materials will turn into the final product. If you get it wrong, you will find that you have something left over. Wow! In 1869, the Russian chemist Dmitry Mendeleev arranged the known elements according to their chemical properties into the periodic table. Yes, this is more than just a neat way of arranging things. Grouping the elements by their relativity and their masses in the way that Mendeleev did reveal a patterns which reflects the internal structure of the atoms and which had predictive power. Missy. This is Missy, right? All of which have since been discovered. It is a standard model. Sorry. I skipped the sentence. Gaps in his original table suggested missing elements, all of which have since been discovered. It is a standard model of chemistry in a sense, and it points rather directly towards the beginning of the standard model of particle physics. Wow! Our explanation of Atomland has shown us as the complex and beautiful array of features and the building blocks of everyday materials. They exhibit some fascinating behavior which we would like to understand better. But everywhere we go in Atomland, everyone we ask to tell us that to understand the economy and ecology of the place grasps how its denizens really interact with each other. So how its denizens really interact with each other, we must return to photoelectron. Thank you.